Dear students, today I am going to explain you some questions of geometric progression. The first question is find the sum of the series 1 minus 1 by 2 plus 1 by 4 minus 1 by 8 plus and so on to n terms. Here we find a equals to first term, that is 1. Common ratio equals to second term by first term, that is minus 1 by 2 divided by 1 equals to minus 1 by 2. Sum to n terms when r is smaller than 1, that means common ratio is smaller than 1. As here minus 1 by 2 is smaller than 1. So Sn equals to a into 1 minus r to the power n by 1 minus r. And that is equals to 1 into braces 1 minus 1 by 2 to the power n by 1 minus and into 1 minus 1 by 2. This is equals to 1 minus, in the parenthesis, minus 1 by 2 to the power n by 1 plus 1 by 2. So this is equals to 1 minus, in the parenthesis, minus 1 by 2 to the power n by 2 plus 1 by 2. And this will be going up in the numerator. So this becomes 1 minus, in the parenthesis, minus 1 by 2 to the power n by 3 by 2. And then this is coming this side, so it becomes 2 by 3. And it is, in the braces, 1 minus, and this can be separated. This n power is for 1 as well as 1 by 2. So this is written as minus 1 into 1 by 2. That means you can say that minus 1 by 2 is written as, minus 1 by 2 can be written as minus 1 into 1 by 2. And that's why here n power is for both. So minus 1 to the power n and into 1 by 2 to the power n, that is 1 by 2 to the power n. Because 1 to the power n is always 1. So now this becomes 2 by 3, 1 plus minus 1 to the power n into minus 1 to the power 1 into 1 by 2 to the power n. Because here it was minus, and that minus I have removed and make it plus, and here minus 1 to the power 1 I have written. So this in multiplication base is same, that's why power will be added. And so we get 2 by 3 in the braces 1 plus minus 1 to the power n plus 1 into 1 by 2 to the power n. This is our answer. Second question is find the sum of the geometric series root 7, root 21, 3 root 7 and so on to n terms. So solution is, here we find a equals to first term, that is root 7. Common ratio equals to second term by first term, that is root 21 by root 7. Root 21 means root 3 into root 7 by root 7. Root 7 cancel. So root 3 is the common ratio, that is r. And you know, sum to n terms when r is greater than 1, as root 3 is greater than 1. So Sn equals to a into r to the power n minus 1 by r minus 1 equals to, a value is root 7, so root 7 into, and r value is root 3, so root 3 to the power n minus 1 by root 3 minus 1. This is equals to root 7, and root 3 means 3 to the power 1 by 2, so this becomes 3 to the power n by 2 minus 1 by 3 to the power 1 by 2 minus 1. This is our answer. Now third question is, the sum of some terms of a geometric progression is 315, whose first term and the common ratio are 5 and 2 respectively. Find the last term and the number of terms. The solution is, here you find let there be n terms in the GP with first term a equals to 5 and common ratio r equals to 2. Now sum of n terms when r is greater than 1, Sn equals to a into r to the power n minus 1 by r minus 1. Here Sn equals to 350, it is given in the question. So we are writing Sn equals to 315 implies a into r to the power n minus 1 by r minus 1 equals to 315, implies that a value is 5, so 5 into r value is 2, so 2 to the power n minus 1 by 2 minus 1 equals to 315, implies that 2 to the power n minus 1 by 1 equals to this 5 is coming below 315, and then we divide it and we get 63. So 2 to the power n minus 1 equals to 63. This 1 is coming this side, so it becomes 64. So 2 to the power n equals to 64, and 64 means 2 to the power 6. So 2 to the power n equals to 2 to the power 6. Therefore, n equals to 6, which is the number of terms. And now we have to find the last term. Last term is equals to formula a into r to the power n minus 1. Here n minus 1 is the power of r. Here a is 5, r value is 2, n is, just now we have calculated 6, so 6 minus 1. So 6 minus 1 is 5, so it becomes 5 into 2 to the power 5. 2 to the power 5 means 32. So 5 into 32 is equals to 160. This is the answer. Thank you. If you like, please share and subscribe.